we're going to do some more examples of Lewis dot structures. And so the first one we have is H2CO. And so we're going to follow our steps, determine how many valence electrons are in each atom and the overall structure. So I know I have one valence electron for hydrogen. There are two of them. I know that I have 4 valence electrons for carbon and 6 valence electrons for hydrogen. That gives us a total of 12 for the overall molecule. This information will be useful more when we have multiple possible structures, not when we have a single possible correct structure. And so the second step is to place the heteroatoms and the carbons on the inside and the H's on the outside. So I'm going to put carbon here. It has 4 valence electrons, and oxygen has 6. And I'm going to put the H's on the outside. So I'll put an H there and an H there. All right, so I'm going to connect these bonds. And now I'm like, okay, well, this oxygen has 8 valence electrons, so it's happy. That carbon, however, has 2, 4, 6 only. So 2 in this bond, 2 in that bond, and then 1, 2 each as an electron. So it's got 6. So did that mean it's octet? No. So this is not likely the correct structure because not all the octets are fulfilled, right? And so I need to come up with a different possibility. And so here's what I'm going to do instead. We'll go ahead and move over. And so we have carbon on the inside again, oxygen on the inside again. But instead, I'm going to go ahead and put the H's on the outside of the carbon only. Instead of 1 on each, on the outside of each, I'm going to put the H's both on the carbon. Now, the structure already suggests that the 2 H's are on that carbon, but I drew it incorrectly to show you, or I drew it in another way to show you that there are multiple possible attempts at getting the right structure. So if you don't get it on the first try, that's okay. You need to reassess what needs an octet. And so I'm going to take this electron and that electron to form a bond, and we'll move up here. And so that would leave a double bond to oxygen. It's got its lone pairs and H bonded, both H's bonded to the carbon. Let's take a look. I've got 8 electrons here, 8 electrons here, 2, 4, 6, 8, and then I've got the duets on my hydrogen. So this satisfies, so step 3 is determine if each molecule meets the octet rule. So this is going to be my correct structure. Right? And so we move on to another problem, and we'll follow the same steps. We have CH3COOH. So determine the number of valence electrons in each atom and the overall molecule. So we have 4 electrons here, 1 in each hydrogen, there's 3 of them, 4 electrons in that carbon, 6 in that oxygen, 6 in this oxygen, and 1 electron there. That gives us 12. That gives us 16, 17, 18, 19, 20, and then 24 total. And so let's take a look here, and we're going to go ahead and start putting things on the inside. So I'll put that first carbon, which is a heteroatom or carbon, go on the inside. There's that second carbon, and that's going to go on the inside. I'm going to put my oxygens on the inside. And now I'm going to start connecting the bonds. And so I have 3 hydrogens there, so I'll put the 3 hydrogens this time, maybe learning from the last problem, and that they're likely written together for a reason, not always. And so you have your CH3. Now, here's the thing. What if I take an electron from there, and form a bond? And so I have Let's take a look, count valence electrons. I've got 2, 4, 6, 7. I have not met the octet for oxygen, so that's dissatisfied. I've got a lone pair, a lone pair here, and now an electron there. That's 2, 4, 6, 8, 9. Ooh, nope, that's not good. And then 2, 4, 6, 7 valence electrons. That's not good. So I can keep going and playing with this. And again, I'm giving you multiple attempts to show you that you're going to try and play with this. You're not necessarily always going to get it right away. Some are easier to figure out than others. Let's say I take this electron, that electron, and now I have something like this. Let's take a look. I've got 2, 4, 6, 8. So this guy's happy. This oxygen has, and I forgot the lone pair, 2, 4, 6, 8, 10. Ooh, no. And then this oxygen's 2, 4, 6, 7 again. So this is not the right valence, the right Lewis dot structure. And so I'm going to do another attempt. This time, instead of putting the two oxygens together, because an oxygen-oxygen bond is rare in organic chemistry. It can happen, but it's rare. And so instead, I'm going to put both oxygens around the carbon. So I'll put my oxygen there and another oxygen here. And then this carbon, which was doing fine over there with all the H's around it. Connect these bonds. Okay, so here's what I'll do. And I'm forgetting that H. And so I'm going to put the H on the outside of one of these carbons. So let's say I put it on this guy. Oh, well, great. This leaves a lone pair here and a lone pair there. And so now I'm going to go ahead and draw the final structure. And now if I do my counting, I'll have 8 valence electrons here, 2, 4, and then 6, 8. And then for that carbon, I have 2 in this bond, 2 in that bond. So 2, 4, 6, and 8 here. This is also satisfied. I've got 2, 4, 6, 8 in my last oxygen. And therefore that's satisfied. And we know that that carbon also has 8. So this is going to be the correct Lewis structure. Now again, we went through multiple attempts. As you get more experience, you're going to get better at figuring out, oh, it's probably not a good idea to put an OO bond next to each other. Oh, it's good to have that oxygen in a double bond with a carbon. So you start picking up the patterns with these structures. But I did it for you in a roundabout way, so that way you can see when doing these Lewis structures, you may need to have multiple attempts to get where you want to go. And so lastly, we're going to make sure that we go through each step to make sure we don't miss anything. The last problem, CH3, CHO, we're going to go ahead and do our same thing. We're going to count. So I have 4 electrons there. And then I have 3 hydrogens, each with 1, another carbon, so that's 4 electrons, a hydrogen, that's 1, and then oxygen, 6. So if we do the math, we got 6 and 4 is 10, then you have 3 and 1 hydrogen, so that's 14 plus another 4, that's 18 total. Okay, and so now we're going to do the same. We're going to put heteroatoms and carbons on the inside, so I'll put my first carbon from left to right. Then I'll put my next carbon with 4 valence electrons, again, because it's in group 4. I'm going to put my oxygen next to that, and I'm going to try to put that H on the outside. But first, I'm going to go ahead and connect some of these bonds. And I'll put my H's on the outside of my carbons. And then next, I'll go ahead and try to add these into a bond. So that looks like this. And now I have a electron. And so we have 1 remaining hydrogen. So if I put that hydrogen there, and now I can count my electrons. So I have 8 around this structure because I got 2, 4, 6, 8. And then for carbon, I have 2, 4, 6, 8 in those bonds. And then in that carbon, I have 2, 4, 6, 8. So this is the correct structure.